This is Algebra 2 at Trig, Semester 1 exam review, looking at Chapter 7. This might be Part 1 of Chapter 7. We're going to identify the domain and the range of our function. So we're looking here. This is exponential. So thinking about what the graph might look like, we know this is exponential decay. Because your b value is less than 1, this is y equals a b to the x power. And this actually has an h value with it also, or k value, sorry. This is exponential decay because the b value is less than 1. This is a stretch. It is stretched by a factor of 3, because that's the number that's in front, and it's translated 5 units down. So first off, it might look something like this. That would be a y equals half x. The stretching's not going to make a big difference in the domain and the range, but when we drop it down 5 units, we're going to have, so we're looking at how far we come down, which is y equals -5. So we know that our range is going to be from -5 and up. So that's making this look good. That's making that look good. You can plug in any value, positive or negative x values. So that's why it's going to be all real numbers. We're going to identify the equation that would be used to solve the given problem. Suppose you deposit $200 into your bank account. Find the balance after 5 years if the bank account pays 2.5% of annual interest compounded monthly. Well, the formula that we're looking for here is A equals P, 1 plus R divided by N times T, where P is the 2,000, R is your interest rate, which would be 0.025. Compounded monthly means you're going to take the 2.25 and break that into each month. So there are 12 months. Your N is still 12, and the number of years is 5. So looking through here at what would be possible, here 2.5 is incorrect, so that's ruled out. That one's looking pretty good. Here they put the wrong value up in the exponent, and this isn't an x problem, so this is C. So you want to be sure to look through the answers, even when you think you've narrowed it down. Just pay attention to some of the other ones and specifically be able to rule something out. Number 3, evaluate the expression. So here, E, remember, is 2.78. So using our calculator, we would type in 2 times e to the 3rd power, and we get 40.17 approximately. Number 4. Find the domain and the range of the function. Well, this is a logarithm. When I do domain and ranges, I like to think about what the graph would look like. So the parent function of a logarithm looks like that, where it's all the values greater than your asymptote, and your asymptote goes straight down. This is going to be translated 3 units to the right. Kind of something like that. So your domain is going to be x values greater than 3. So that's going to rule this one out, and it's going to rule that one out. And your range, you're going to go up forever and down forever, so it's all real numbers. So here's greater than 3, all real numbers. Greater than -1, well, I'm much more than -1. So answer again is C. Evaluate the expression. What is log base 2 of 1/4? Well, how we would do this, we're looking at the value of what the logarithm is. So for us to make that happen, we want to make what we're taking the logarithm of with the same base. So to do that, we know that we need a negative exponent to make it from a fraction, or the fraction to a non-fraction, really. And we square it to get to 4. So the answer here is going to be -2. Another way you could look at that, you could think about it as the change of base formula. If you couldn't come up with it on your own, you could possibly do a change of base formula, which would be the log of 1/4 divided by the log of 2. And here they all seem to be calling it approximate. It would be an exact answer, actually, but identify the transformations that took place from the parent function to produce our equation here. Well, I can see that there's no reflection because there's no negative in front. There's a vertical stretch. That's your A value by a factor of 2. There is a translation 3 units to the left and 4 units down. On our next page, we're going to find the inverse of our function. This here is a logarithm, so I know the inverse of a logarithm is exponential. So my answer has to be some sort of exponential. So I can already rule out A and C. So that helps me narrow down what my options are. Let's take a look. Currently we have y equals log of 3x minus 1. We're going to switch our x and the y. Now we need to solve for the y. Well, to do that, we see that the logarithm has a base of, nothing's written, so that means it's a 10. It's called a common log. So 10 is your base. Your exponent will be the x, because that's what a logarithm always equals. 3y minus 1. So we're going to add the 1 across, and then we're going to divide by 3. So looking at which options would work there, it definitely looks like D. Our next problem, we are going to graph log base 3 of x plus 2 plus 3. So we'll start out with the parent function. Which is y equals log base 3 of x. To do that, we like to write this in exponential form. 3y to the x. Remember, logarithm equals the exponent, so 3 is our exponent. So to help us decide where our coordinates are going to be, we pick values for y. We can pick -1, we can pick 0, 1, and 2. -1 would give us 1/3, 0 would give us 1, 1 would give us 3, and 9. So looking at our graph, when x is just 1/3, we're down at -1. X is 1, we're at 0. When x is 3, we're at 1. We're up at 2 when we're way out at 9. So knowing logarithms approach a vertical line. Our vertical line that we would have, our asymptote, would be, in this case, x equals 0. So this is y equals log base 3 of x. But what we want to do is do a translation to this. So for a translation, we're going to move over the graph 2 units to the left and 3 units up. Translation. So our h value is -2 and our k value is 3. So I'm going to take each one of these points and move 2 to the left, 3 up. You just have to remember to respect that asymptote that's also going to move over. And that asymptote is now at -2. Our equation is log base 3 of x plus 2 plus 3. So looking over at what our domain would be, our domain would be all the x values that were greater than -2. That would have an interval notation from -2 to infinity. The range is all real numbers, which is from -infinity to positive infinity. And the asymptote is at x equals -2. We're going to condense. Here we have 3 different logarithms. We're going to write a single logarithm. Look at your first two. Work from left to right. This is minus, so that means there's going to be a division sign. So we're going to say log x divided by y plus the log of z. Well, we know plus means multiplication. So the z is going to go up with the x. So this is going to be log xz over y. If it was another minus, then it would go down with the denominator, Because it's a positive, it stays up with the numerator, just like any number would be. So that's going to be our A value is going to match that. This here most likely meant that it was going to be a multiplication symbol. So 9 was A. We're going to condense. We're going to bring it down to a single logarithm. The number in front goes up as your exponent. And then adding two logs together means that we are going to multiply what you're taking the logarithms of. And the parentheses would mean that you're taking the logarithms of both of those. Which of the following statements are not correct? So what they're looking at here is we have a base of the logarithm. So the 3, of course, is correct. 48 is broken down by 16 and 3. Let's take a look at what we could come up with if we did it completely on our own. Okay, we know that we could say 6 times 8 is 48. That would be one way to do it. And so that would be log base 3 of 6 plus log base 3 of 8. Now 8 can be written actually as 2 cubed. That's a value of 8, so we can bring the 3 in front. See if they have that option. That looks like that's B. Okay, so yes, this is what that would break into. But watch carefully, this is saying which is not correct. Yikes. So here we're adding 16 times 3 is 48, so that would actually be an appropriate way to do that. You can break 16 down into 2 squared to bring, or 4 squared to bring the 2 in front, so that would also be correct. We already showed that that was correct. So this one here would be log base 3 of 8 plus log base 3 of 3 squared, which would mean log base 3 of 8 plus log base 3 of 9, which is actually log base 3 of 72. That is not equal to log base 3 of 48. So that's the one that is not correct. So watch carefully at what they're asking. Last one I'll do on this video portion. Which of the following statements is equivalent? So we want to take this, we want to break it down. So we're going to take log base 9 plus, well, it's not base 9, sorry. This is a common log, so it's really log base 10, but we'd say log 9 plus log 2 cubed minus log 3. That would leave us log 9 plus log 8 minus log 3. That would be log of 72 minus log of 3. And then that would be log of 72 divided by 3, which would be log. 3 goes into 7 twice with 1 left over. Looks like log of 24. So it looks like that's letter D.